Hello, and welcome back to Dr. S's Random Math Layer. Today's video will cover vertical motion involving gravitational acceleration from undergraduate calculus and classical physics, in the form of problem 2. Please be sure to click subscribe at the end, if you enjoyed this video. Thanks. Here's the statement of problem 2. A ball is thrown straight upward from the ground with an initial velocity of 20 meters per second. First, find the maximum height possible that the ball can attain. Second, find when the ball returns to the ground. Here are some quick facts and review that we will need to solve this problem. Since we are considering the vertical motion of a body, the natural choice for our coordinate system is the y-axis for position, where y equals 0 corresponds to the ground level, so to speak. Choosing the upward direction as positive, the force of gravity acts on the vertically moving body, decreasing its height and also decreasing its velocity v, which is equal to dy dt. Here the variable t is time in seconds. Ignoring air resistance, as we shall do, the body's acceleration a, given by dv dt, is now set equal to negative g, where g denotes gravitational acceleration, which is about 9.8 meters per second squared. We label this as 1. Successive integrations of 1 yield the following formulas, 2 and 3, where v of t is the body's velocity at time t, and y of t is its height, or position, at time t. In addition, v0 is the body's initial velocity at time t equals 0, while y0 is its initial position at time t equals 0. Now let's solve problem 2. For part A, we know the ball has an initial height of 0 meters corresponding to the ground level, with an initial velocity of 20 meters per second, and that the acceleration due to gravity is 9.8 meters per second squared. At time t, the ball's height function is given by y of t equals negative 4.9 t squared plus 20t. The ball's velocity function at time t is given by the first derivative of its height function, that is, v of t equals negative 9.8 t plus 20. The ball attains its maximum height possible when its velocity function is set to 0. Solving for t, it follows that the ball attains its maximum height possible at time t equals about 2.04 seconds to the nearest hundredth. We are not done yet, as we need to find this maximum height, which we shall do next. We continue to solve problem 2. From where we left off in part A, plugging in the value of t equals roughly 2.04 seconds into the ball's height function tells us that the ball attains a possible maximum height of about 20.41 meters to the nearest hundredth. Now for part B, the ball returns to the ground when the height function is set to 0. Using the quadratic formula, with y of t equal to 0, we solve for t. We obtain two values of t, 0 seconds and about 4.08 seconds. For the first value at time t equals 0 seconds, we have y of 0 which equals y0, and this is equal to 0 meters. But this is the initial position, or height, of the ball before it is thrown in the air. So we cannot use this value of t. Hence, the ball returns to the ground after about 4.08 seconds in the air.